Hey guys, good morning. Today we're going to take a look at some dosage calculations. I mentioned to you guys last week that that's what we were going to take a look at today. Dosage calculations, if you're following along in your syllabus and in your book, it does say that we're going to take a look at chapters 12 through 14 today. Chapter 12 just kind of introduces the different methods that we can use, and then chapter 13 and 14 are both dosage calculations. So just really kind of sticking with I typically just use one formula and stick with that formula for all of these chapters. So really not too bad at all. So if you want to follow along in your book, chapter 12 starts on page 252. So that just again introduces the methods for dosage calculations. As you guys are getting to that page, I just want to give you guys an example of a dosage calculation. We did look at one last week, but just to jog our memory at what we looked at last week, just to give you guys an example, if say, typically this is how you guys are going to see it. There's a certain amount that's ordered, and then based on that drug itself and how that medicine comes, I'm going to list that as what we have. So meaning after we look at the label, for instance, we can see that here's what we have. The example that I gave to you guys last week said this. If we ordered 50 milligrams of a particular drug, and I know we went a little bit further with that when I said by mouth, every 12 hours, but we'll get into that in just a minute. But if, say, a doctor ordered 50 milligrams of some particular medication, and we look on that label, and the label says that they are 10 milligram tablets. So we can see that there's 10 milligrams for every one tablet of that drug. Well, you guys hopefully are looking at this right now and saying, oh, well, that patient needs 5 tablets then. And that's absolutely true. If they need 50 milligrams and there is 10 milligrams for every one tablet, then they would need to take 5 in this case. And what you guys are looking at is an example of a dosage calculation. And what we can look at in chapter 12, it does introduce that at the bottom of page 252 and even going up at the top of page 253, it introduces for us a formula that you can use to calculate these if they aren't as easy as like the one we have on the screen here. This is one that you guys may be able to just do in your head. If that's the case, do them all in your head. It would be much better if you could do them all that easily, and that would be fantastic. But if you can't, there is a formula provided for us that would make that a little bit easier. And that formula says this. It says D divided by H times Q. D divided by H times Q, or D over H times Q. We'll see that formula as we go through the next couple chapters. What it says on the bottom of page 252 and on page 253, it tells you guys what those things are as we go through these different examples. And I'll just tell you guys here, D stands for, actually, let me get that answer, 5 tablets, out of the way. So D stands for the dosage that's been ordered. So however you guys want to remember that, if you remember that as dosage ordered, or perhaps even doctor's order, but that in our example was the 50 milligrams. H is another dosage, but H is the dosage that we have on hand. So when we looked on the label and saw how that medication comes, that was that dosage strength for that particular medication. In this case, in our example, it was 10 milligrams. And then our Q stands for our quantity. If you guys remember when we were talking about dosage strengths, that, there's a certain amount of medication per a certain amount. In a tablet medication, it's always per every 1 tablet. But in liquid medications, you might see per 5 milliliters or per 2 milliliters, what have you. That may be different sometimes. But in this case, it's just 1. So you guys probably looked at this and did it in your head. And again, that's how we got the 5. But how we would solve these equations anytime we aren't doing them in our head, you simply just take D, divide it by H. So in our last example, it would be 50 divided by 10. And then obviously that's 5. And then we take that and multiply it by the quantity. So in this case, 5 times 1 would still just be 5. And that's why we got our answer of 5 tablets. So another thing I want to point out with the use of this formula is you'll notice that the unit of our answer, tabs, happens to match the unit of our quantity. And that's how it should be. Obviously, a medication comes in tablets. We're going to give them tablets. If a medication comes in milliliters, I'm going to give them milliliters. So, that'll always be the case. And I point that out because in this equation up here, so just in this part of the calculation, I'm eliminating the answer. This is what came in later. But in just the calculation there, we took milligrams divided by milligrams times tablets. The reason why I show that is because D and H are the same unit in this example, what happened in this problem is the units that are the same, what happens is they actually cancel each other out. The same way in like a fraction, say in the fraction 3 over 3, those pretty much just cancel each other out and that gives you 1. Same thing happens when we're dealing with units. So with different units, as long as the order dose and the dose that medicine comes in are the same unit, then you're good. You want that to happen. You need D and H to be the same unit, always. And that makes sense. If doctor orders milligrams, but that medication comes in grams, we're going to have to do some changing around. So we'll get to that a little bit later, but that I wanted to point out when we see that first example on here. So again, some things to remember just as you guys are writing your notes down. Remember our formula that we're looking at is D over H times Q, or D divided by H times Q. Don't forget D stands for the dosage ordered. H is the dosage that we have, or the dosage that we have on hand, and then Q stands for the quantity on hand. So H and Q are always going to be listed together in our problems here. So like I said, our last example was 10 milligrams per tablet, or per 1 tablet. So that was our H and this was our Q. Those are always going to be listed together in these questions. D is just given to us as our ordered dose. And again, don't forget your one stipulation for this is just, and again, if you're just making notes in your notebook there, your one stipulation says that D and H must be the same unit. So we'll write that. Must be, sorry, my handwriting is sloppy on this tablet here. Must be same unit. Always. Always, always, always. Like I said, what's going to happen is we'll have to adjust that later. If doctor orders grams and it comes in milligrams or vice versa, we need to do some adjusting. So just looking at some sample problems as we're going through this in the book here, there's all kinds of crazy problems that you guys will see. But again, this chapter 12 just kind of introduces that method that you can use. There's different methods that it gets into. It gets into how you can use the proportion method. The proportion method just uses a known and an unknown, and that's what it talks about on page 240 or 254. That, and we've seen proportions before. It just talks about how we can use that the same way. In that previous example, we could have said, well, if I know that there are 10 milligrams per 1 tablet, and I want to know how many tablets contain 50 milligrams. Again, if you guys recall with our proportions, we can set up known equal to unknown, simply just making sure our units match up, and then to solve this we would cross multiply the side away from our x, 50 times 1, and divide it by 10. It just shows us that we could use that method the same way, but I tend to stick to the dosage formula as I think it's something that's a little bit easier to follow, as it's just kind of set in stone. And it's just, in my opinion, it's just easier to follow that formula. But that's totally up to you. If you guys would rather see that proportion method, that works too. Over on the next page, it introduces a method called dimensional analysis. Since we haven't seen that yet, I tend to kind of stay away from talking about dimensional analysis, simply because it's just a little bit different. It's very, very similar to proportions, but just a slightly different setup. So that's there. If you want to take a look at it, you're welcome to. But I tend to stay away from dimensional analysis since it is completely brand new. But I want to show you guys what happens in these types of problems. If you look at the bottom of page 257, since that's where we are in the book here, at the very bottom of page 257, I want to start with number 3. On number 3, on page 257, it says what's ordered is phenobarbital, 30 milligrams by mouth 3 times a day. So I'm going to just go ahead and write that down up here. This is our ordered dose, so that's 30 milligrams, and again, POTID, so we know that that's by mouth 3 times a day. What we have, when we look on the label, it says that phenobarbital is 15 milligrams per each tablet. So 15 milligram tablets. So again, in following our D over H times Q, what's going to happen is our order dose is 30 milligrams. That's the dose that we have. That's the dose that's been ordered for us. Again, H is also a dosage, but it's the dosage that we have on hand, so how that medication comes. Q is our quantity on hand, so again, it was our 15 milligrams came in every one tablet, so that's our quantity in this case per every one tablet. So when I go ahead and divide this, 30 divided by 15 is 2, times 1 is still 2, so this would be 2 tablets is how much they would have to take. What's going to happen in these questions, guys, when we get to these on your homework and on your quiz, it's going to ask you guys, or I definitely know what happens on your quiz. It may not on your homework. But what I'll do is I'll ask you guys, how much do we give? Okay, so we saw here that we would give 2 tablets to this individual. But then I may ask you guys then too, how much would we give daily? And so that's based on this. Remember those abbreviations that we talked about last class? TID stands for 3 times a day. So if they need 30 milligrams 3 times a day, remember that means they're going to receive 2 tablets 3 times a day. So daily then, if they're getting 2 tablets 3 times a day, 2 times 3, that means they're going to receive a total of 6 tablets in a full day. So keep that in mind as you guys are going through these types of questions too. I may ask you guys what they would get daily, and that is simply just based on that medical abbreviation that tells us how many times a day they need to receive it. So that's just one example there. One other thing I want to also point out there on page 257, go to say number 1. Number 1, just in that on that same area there, just above it. Here's what I was talking about with what we talked about earlier with how D and H need to be the same unit. Remember we talked about that just a few seconds ago, but on this one, that's what's going to happen here. Amoxicillin is a tablet or a capsule medication, but it says that amoxicillin was ordered, let me change my pen color here, 0.25 grams. Grams, P-O, and then it says QID, so 4 times a day. So this is our order dose. The dose that we have on hand says that amoxicillin comes in 125 milligram capsules. Okay, so when I go to fill out the D over H times Q formula now, say I did that without looking at, the units there. Doctor's order is 0.25 grams. The dose that we have on hand is 125 milligrams. And the quantity is, again, per every 1 capsule. Okay, so that's what D over H times Q looks like right now. But like I said, D and H have to be the same unit. What happens in this particular situation here when they're not the same unit is you simply just have to convert one to the other. It does not matter. What I can do is I can take this unit of grams, the doctor's order, and I could just convert it to milligrams so that therefore they would both be in milligrams, or I could do the reverse. I can forget that and instead I can convert this unit of milligrams down here at the bottom into grams, and then therefore they'd both be in grams. Either one, it does not matter, just as long as you convert one to the other. Now, one thing I will say, and so far in all the examples that we've seen so far, you may notice that the most common unit that you guys will see more often than anything is milligrams. So I am in a habit of getting everything into milligrams, and I suggest that for you guys too. I think that would be really just a great thing it's easier for you to get them all into the same unit if you just make sure that everything is in milligrams. So with that being said, what that means is our dose on hand is fine. It's in the unit I want it to be in. However, what I'm going to do is I'm going to have to take that doctor's order of grams and convert it into milligrams. So again, remembering our metrics, grams to milligrams, that is a base to milli conversion. So that would be either 3 places to the right on our metric chart or down 1 step for those of you guys who are using the stair-step method. So just times 1,000. So either way you do it, that would convert this to 250 milligrams. So again, all we're doing is converting. We're not changing the doctor's order in any way. I'm not, you know, what that doctor has ordered of 0.25 grams, that just happens to be the exact same thing as 250 milligrams. They are one and the same. It's a conversion. The same way that 1 hour is 60 milligrams. I'm sorry, 60 milligrams. 1 hour is 60 minutes. They are one and the same, just a different unit. And so 0.25 grams is the same thing as 250 milligrams. We're just saying, hey doc, that particular medication comes this way, so we want to make sure that we get it to match. So now that we've done that, we're going to use 250 in place of that. We can take 250 divide by 125, that gives us 2 times 1. Our answer then means that our answer is 2 capsules. So that's what we're doing here. And again, that's what we're given is 2 capsules. Going back up to the original problem that said that they would take that QID, again, QID is 4 times a day. So taking 2 capsules 4 times a day would be a total of 8. So remember, we just take our answer, the 2 capsules, and multiply that by 4 to get that. Okay, so let's get that out of the way. Same thing takes place in number 2. In number 2 on that same section, erythromycin, 0.05 grams is what was ordered. So I'm just going to write that down, 0.5, if I said that incorrectly, I apologize. 0.5 grams by mouth every 6 hours. And it looks like erythromycin comes in 50 milligram tablets. So 50 milligram tablets. So again, to put this into perspective here into our D over H times Q formula, that's 0.5 grams as our ordered dose, our D. H is 500 milligrams, and our Q is per 1 tablet. Again, everything we've looked at so far is capsules or tablets, so that's what we're looking at here. Again, D and H need to be the same unit. Right now they are not. So I'm going to do very, very similar to what we did on the last question. I'm going to go ahead and convert my grams into milligrams so that therefore they would then both be in milligrams. See how they would then match if I did that. So converting 0.5 grams into milligrams, same as the last conversion, it would be either 3 places to the right or times 1,000. So 0.5 grams is the same thing as 500 milligrams. So 500 divided by 500 now would give us our answer. That gives us 1 times 1. This person only needs to take 1 tablet based on what they need. So that's the amount that we would give, whereas again, if I asked you guys, okay, well, what would they take daily then? If they're taking 1 tablet in a single dose, they're taking that order dose, again, they're taking that every 6 hours. Here, we talked about this real briefly last week. Remember, every 6 hours would be how many times in a day? In a 24-hour day, and if it helps to see this, in a 24-hour day, every 6 hours would end up being 4 different times. So they're going to take 1 tablet 4 different times. So 4 times 1, they would end up taking 4 tabs daily. Okay, so that's just another example with that one, or with those oral dosages there. So again, Chapter 12 just kind of introduces that. Chapter 13 kind of gets into all those same types of questions. I'm going to see something before we move on to Chapter 13. Yeah, let's go ahead and let's take a look at Chapter 13. I want to show you guys, Chapter 13 is really the exact same thing. It gets into, if you guys look at Chapter 13, hold on, I'm going with you guys, page 291. Page 291 gets into oral dosages. So it's everything we've looked at so far have been oral dosages, just meaning that medications you take by mouth instead of an injection. So they're all going to be set up the exact same way that we saw just a second ago in Chapter 12. The goal of Chapter 12 excuse me, was simply just to introduce you to the different methods. Okay. So Chapter 13, let's actually go find some sample problems here in Chapter 13. It goes through the whole intro to Chapter 13 is showing you guys just different types of oral medications. They could be capsules, tablets, liquids. On page 304, if you look at some sample problems there on page 304, let's go over to page 304 there. On page 304, these are some sample problems using oral medication, or that are oral medications. You'll notice that all of these say either scored or unscored tablets. They're still tablets. Don't be thrown off by tablets, or, in any scored tablets or unscored tablets, the only thing that it means by scored is scored means that they can be split. You guys have probably seen scored tablets before where the tablet kind of looks like this and may have a line going down the middle of it. That simply just makes it easier to cut in half. So this, like I said, you can pretty much ignore the word scored in all of these questions because it's still tablets. It's just telling you guys don't be thrown off if you get 0.5 as your answer, because that would just mean that they would be able to take half of a tablet. They could take 2.5 tablets. So even some tablets are quarterly scored, so meaning they're scored both directions, which means they can be cut easily into 4 pieces if need be. So that's just what that means if you see the word scored. So looking at, say, number one, we've ordered 400 milligrams by mouth, BID. Let me get this tablet out of the way here. So we've ordered 400 milligrams by mouth, BID. And it looks like that particular medication comes in 200 milligram unscored tablets. So it's also telling us that it's unscored because we're not going to be able to cut these in half, so we shouldn't get 0.5 as our answer here, and we don't. Again, setting up D over H times Q, this is 400 as our order dose. Our dose on hand is 200 milligrams per 1 tablet. And so, looking at D and H, they are the same units, so we're good to go on that. They're both milligrams, so we don't have to change anything. So we would just take 400 divided by 200, which is 2, times 1 would still be 2. So they would take 2 tablets in a single dose. But since they're taking that BID, if I asked you guys what would they take in a full day, remember BID is twice a day. So 2 tablets twice a day would be times 2. In a full day, they'll end up taking 4 tablets. So those are your 2 answers for that one. So all of those, again, are all tablets. Everything on page 305, those are all tablets as well. Again, keeping in mind that we may just need to read that off the label. We did that. We had some practice with that last class. Like number 10 at the top of page 305 says that they've ordered 50 milligrams by mouth daily. We look at the label and they come in 25 milligrams per tablet. So we would just take 50, oh, whoops. I mean to do that. Let me get my pen going here. We would take 50 milligrams as our order dose divided by 25 milligrams is what's on the label per, since Clozaril is a tablet medication, it is per 1 tablet, so it would just be 50 divided by 25, which is 2 times 1 would be 2 tablets. And the order dose was to just take this daily, so that was just the daily dose. Flipping through these are all tablet medications, so they'd all be set up the exact same way. I want to get deeper into the chapter. I want to show you guys how even with liquid medications, we'd set them up the same way. Go over to page 318. Real quick there, you can see on page 318, it's actually going to be the same setup. These are included in your oral dosages because these are just liquids that we would take by mouth. So on page 318, I'm looking at 13.2, which says liquid oral medications. Looking at just number 1, in that example, we've ordered 400 milligrams. So 400 milligrams by mouth TID in this example here. And it says on hand, that medication is a liquid that is labeled as 500 milligrams per 5 milliliters. So here's an example of where our quantity might change. And so just don't forget, so far everything we've looked at, our quantity has been 1, so you don't want to forget about the quantity here in this case. So how we would set this up as D over H times Q. Our D, our doctor's order, again, is 400 milligrams. H, our dose on hand, is 500 milligrams per. Our quantity in this case is 5 milliliters. So we would take 400 divided by 500, which gives us 0.8. 0.8 times 5 would be 4. So our answer would be 4 milliliters. Remember, your unit of your answer matches the unit of your quantity. It's a liquid medication, so we need to give a certain amount of liquid. In this case, it's milliliters. Again, if I asked you guys, okay, well, what would they take daily then? Well, based on the fact that they're taking that 3 times a day, remember we saw that earlier in the order dose, so 3 times a day means that we would take 4 milliliters 3 times a day, so 4 times 3 would end up being 12 total milliliters in a day. Okay. Same thing with all these. Make sure we're looking to see if it just says, like on number 3, I'm looking what's on hand in number 3. It says that this is a solution labeled 40 milligrams / milliliter. That means your quantity in that case would also just be 1, like it was in a lot of our previous examples. So we would just be multiplying by 1 in that case. So just that's a big thing you want to look out for on these. Don't forget that quantity as well. Going over to, let's go to the middle of page 319, just on the next page. On page 319, I'm looking at number 8. I'm looking at that amoxicillin. Amoxicillin was ordered. We've ordered 270 milligrams to be taken by mouth every 8 hours. And it says the amoxicillin label, if you guys see that in red on that amoxicillin label, the dosage strength of that one is 250 milligrams per 5 milliliters. Okay, so setting up DH and Q here would be 270 milligrams as our ordered dose. Our dose on hand is 250 milligrams. And our quantity is 5 milliliters. Again, remember D and H are just right here. That's how that medicine comes. So our dose on hand, our dosage on hand, and our quantity on hand. So we're going to go ahead and again, D and H are already the same unit, so I didn't have to do any converting on this one. I'm going to take 270 divided by 250, which is 1.08. Take that and multiply by 5. Our answer here would be 5.4 milliliters. You can give 0.4 of a milliliter, so make sure we have that to the decimal. I wouldn't round that one to the nearest whole number on that one. Make sure we're rounding it and we have a decimal after it. So just an even 5.4 milliliters. Going back up to figure out what we would take in a daily, if I asked you guys the daily question then, based on the fact that they're taking these 5.4 milliliters every 8 hours. Again, when it says every so many hours, you have to consider how many hours are in a full day. So in a 24-hour day, just a little side note here, in a 24-hour day, every 8 hours would end up being 3 different times. Okay, so if they're going to take 5.4 milliliters 3 different times, we need to take 5.4 times 3, and so our daily dose would be 16.2 milliliters. That would be our answer for that. So don't forget to incorporate that as well. Okay, so that's what's happening in these liquid. These are all still oral dosages. We're still looking at the D over H times Q formula, still making sure that D and H are, continually we need to make sure that they're in the same unit. If they're not, we're going to have to do some converting of those. So just looking through some more sample problems here as we go back to, say, the back of the chapter here. I just want to take one example. Let's take a look at page, let's say 327. On page 327, I want to point out, say, number 16. Number 16, we're looking at another tablet medication. Again, don't forget, if our ordered dose is not the same as our dose on hand, we might have to do a little bit of converting. So our ordered dose on number 16 is 0.5 milligrams. Nope, not milligrams, I'm sorry, grams by mouth daily. And then the dose that we have on hand, when we look at that tablet, these are all tablets, and they are scored tablets, so that means we may be able to cut them in half. So if you get a 0.5 answer, don't be thrown off by that. It says that there are 1,000 milligrams in each of these tablets. See that in pink across that label there. Those are 1,000 milligrams. I know it doesn't say per tablet, but in a tablet label, we do assume that that's per every just single, every just one tablet. So setting this up right now, that would mean that our dosage formula looks like this: 0.5 grams over 1,000 milligrams per 1 tablet. D and H are not the same unit, so I'm going to convert. Again, I'm just in the habit of making sure everything's in milligrams. So I'm going to convert that doctor's order from grams into milligrams. That again is 3 places to the right, or times 1,000. That would make 0.5 grams the same thing as 500 milligrams. So when I take 500 and divide that by 1,000, that does give me 0.5 times 1 is still 0.5. So my answer here, they would just take half a tablet daily. So 0.5 tablets is my answer there. Hope everybody sees what we're doing here, that again, it's just following that dosage formula based on what's ordered and based on how that medication comes, and always double check to make sure D and H are the same unit. We actually do the exact same thing in chapter 14, so I'm going to leave that formula still up there because we're still working with that particular formula here. Again, our D, H, and Q formula, so just this one right here. Oops, moving that around there. D, H, and Q formula. And we're just going to apply it a little bit differently. In the next chapter, in chapter 14, starting on page 334. So just moving right along into the next chapter. On page 334, it does mention that we're looking at parenteral dosages. Parenteral dosages, guys, simply just means that these are medications that will be administered via injection of some sort. This is why last week when we looked at those different abbreviations, I did point out that I wanted you guys to be familiar with the abbreviation intradermal, so ID for intradermal, IM for intramuscular, subcut for subcutaneous, and IV for intravenous. If you look at the top of page 335, you can see, for example, that's what all of those injections are, that all of those injections will go in that way. Intradermal means it's going into the dermal layer of the skin. Hopefully you guys remember that from anatomy. Intramuscular means we're going into the muscle layer, so we're going beyond the skin. Subcut means the subcutaneous, which is that layer of adipose or fat tissue that's underneath your dermis. And then IV means that it's going directly into a vein, so it's going directly into your bloodstream. So when you see those abbreviations, that's simply just telling us how that would be administered, but we're not seeing much of a difference as far as doing the dosage calculations. We're still going to follow D over H times Q as we perform these calculations here. There's only a couple slight differences. If you stay on page 335 there and look at that green table, on that green table, it's pointing out just a few ways that might be a little bit different as far as how we may see these medications in this chapter. As IV medications or any parenteral medication, sometimes you might have a limited amount of space on a vial where this injection or this syringe is going to draw up that fluid. So they list them a little bit differently on those vials. So how we're going to see the dosage strength on these might be a little bit different. You still may see them like on the very first one where it says the compazine, that's 5 milligrams per milliliter. We saw a number of those in the last section. You may see units in this case. Don't be thrown off by units. If something comes in units, chances are the doctor has ordered that in units. So again, D and H are going to be the same. You'll be okay on that one. It's the second two that you guys are seeing are beneath that when you guys are looking at the lidocaine 1% and the epinephrine 1 to 1,000. So I'm going to start by looking at that epinephrine one just to show you guys what happens in a scenario like this. So just to kind of block this off a little bit here. So let's say doctor ordered a certain amount of epinephrine. Say we've ordered, I don't know if this is going to work out or not, but let's say we've ordered 5 milligrams of epinephrine. We look on that vial and what it says is that we have epinephrine is a 1 to 1,000 solution. So we have 1 to 1,000 epinephrine. Anytime you guys see a ratio in terms of solutions, what that ratio simply means, as it shows you over on the right-hand side, over on the right hand it says that this means that 1,000 milliliters contains 1 gram of epinephrine. So that ratio shows us there in a 1 to 1,000 solution, that shows us how many grams we have per so many milliliters of liquid. So there is your H and your Q in this particular problem. So if we did go ahead and go and set that up, that means our D over H times Q formula would say 5 milligrams, our H is 1 gram, and our Q is 1,000 milliliters. That's all that means. It's just a shorter way of saying 1 gram per 1,000 milliliters. But one thing you definitely want to pay attention to on this is make sure we see that that 1 is in grams. As you guys can see on the formula we have here on the screen, our order dose was in milligrams though. So we're in a habit of getting everything into milligrams, so you may end up having to convert that 1 gram And 1 gram, 3 places to the right, or times 1,000 would be 1,000 milligrams. So when I go to complete this now, I'll end up taking 5 divided by 1,000 times 1,000 would end up just being 5 in this case. But no matter what your ratio is, it doesn't always have to be a 1 to 1,000 solution. Say we've ordered, let's say we've ordered, once again, let's just do 5 milligrams of something. And we look on that vial and it says that we have a 2 to 500 solution. Again, we see another ratio, so 2 numbers separated by a colon here. In terms of a solution, once again, remember that that means that we have this many grams, so 2 in this case, per the second number of milliliters, so in this case, 500. So filling out our DH and Q formula here, our order dose would be 5 milligrams. Our H, the dose that we have on hand, is 2 grams, and our quantity is 500 milliliters. So that's just, again, like I said, 2 to 500 just is a shorter way of saying that we have 2 grams per 500 milliliters. So we fill out that H and Q in that case with that ratio, and then don't forget you may have to convert. So since our order dose was in milligrams and our H is in grams, I'm going to go ahead and convert that to 2,000 milligrams in this case. So therefore they're both in milligrams. So to get this answer, I'm going to take 5 divided by 2,000, then take that and multiply by 500. My answer here, this person only needs 1.25 milliliters. So that just shows you if you ever come across a ratio as your have or as your H, just keep that in mind that a ratio means that many grams per that many milliliters. Very same thing. If we go back to that chart that's on page 335, we were looking at the epinephrine as that example, but the other example I want you guys to take a look at is that lidocaine. It says lidocaine is 1%. Actually, a percent we can actually look at the same way we just looked at that ratio. So just to give you guys an example, let's say, once again, we're looking at an ordered dose here. So we've ordered, once again, let's say 5 milligrams of lidocaine, and we look at that label of lidocaine, and that means we have a 1% solution. So what's easy about this is you can look at this the same way we looked at those ratios, and then you just kind of treat it the exact same way. With this, what I mean by that is think about what a percent means. Think about when we talked about percentages. Percents were always out of what magic number? 100, right? So a 1% solution, a 1% in terms of anything, a 1% on a test would mean that I got a 1 out of 100, right? Or a 1 to 100 ratio. And then in solutions, we look at it the same way. That 1% simply means 1 to 100. So we look at it the same way we just looked at those ratios a second ago. This just means we have 1 gram per every 100 milliliters. And that's what it says on that table there. It says that 100 milliliters contains 1 gram of lidocaine. That's just what it means simply. So filling out our DH and Q, we have 5 milligrams as our ordered dose. H is 1 gram, and our Q in this case would be 100 milliliters. Your Q will always be 100 milliliters every time we're working with a percent solution, because again, it's always out of 100, if that helps you on that one. But once again, because D and H do not match, we need to make sure we get them to the same unit. So I'm going to convert that 1 gram to 1,000 milligrams. And so in order to complete this problem, I will take 5 divided by 1,000, take that and multiply by 100, and I get my answer as 0.5 milliliters. So that just shows you anytime we come across a ratio or a percent to be on the lookout for that. So let's go to some sample problems. Let's take a look at, where would we see some sample problems with this? At the very end of the chapter, I believe, going to page 359. This is really the only thing that makes chapter 14 different than the previous chapters we were looking at, is when we see these ratios and these percentages. So again, we're looking at page 359. I'm looking at the examples there on that page. Page 359, I'm starting with number 1 there on page 359. It says we've ordered magnesium sulfate. The ordered dose is 750 milligrams stat, which just means immediately. And then on hand, we see magnesium sulfate, so I'll just put on hand here. On hand, we have a 20% solution. So thinking about what we just took a look at with 20%, we know that percentages are always out of 100. So this is actually the exact same thing as saying a 20 to 100 ratio. Means the exact same thing. And all ratios, as we just looked at, all ratios means grams to milliliters. It's a liquid solution. So when filling out our DH and Q formula, this would be 750 milligrams over 20 grams. Again, don't forget that ratio, that means grams per 100 milliliters. Okay, so again, to make sure that they're both in the same unit, I'm going to convert those 20 grams to 20,000 milligrams. Like I said, grams to milligrams, we've done so much with those metrics. That's 3 places to the right, or times 1,000 on our stair-step chart. So hopefully we've got those down. So we know why we did that. So I take 750 divided by 20,000, and I take that and multiply by 100. And so my answer here, this person would take 3.75 milliliters. I know on page 359 it's showing us those 2 syringes because we did go over 3, so we would fill a 3 milliliter syringe, and then the other syringe we could take to the 0.75 or fill them up halfway. Either way, if I did have you guys fill out a syringe for me like I did on today's quiz, it would be just on 1 syringe. I wouldn't have you guys fill out 2 syringes. Flip over to the next page and let's look at another example then. I'm going to take a look at, let's go to let's just look at number 3. Number 3, looking at another epinephrine example. So number 3, we've ordered epinephrine. It says we've ordered 0.3 milligrams subcut stat. So again, in the subcutaneous layer, stat, just meaning quickly. And on hand, epinephrine is a 1 to 1,000 solution. So filling out our DH and Q, just the same way we look at any ratio, remember that 1 to 1,000 means 1 gram per 1,000 milliliters. It's just a shorter way of saying that, just as we've seen in all of our problems. But filling out DH and Q, our D is 0.3 milligrams, H is 1 gram, and Q is 1,000 milliliters. And so again, we need to make sure D and H are the same unit, so I convert the 1 gram to 1,000 milligrams. In order to finish this, we would divide 0.3 divided by 1,000. Take that and multiply by 1,000. My answer here would be 0.3 milligrams. 1 to 1,000 solutions are pretty easy because if our ordered dose is in milligrams, it's going to match that ordered dose, if you happen to notice that in the ones that we've done. So really, you're going to see the same thing in number 4. The adrenaline, they've ordered 0.5 milligrams, and adrenaline is a 1 to 1,000 solution. Your answer there is going to be 0.5 milligrams. Just kind of heads up on that. But you could still fill it out accordingly, the same way we did on the screen up here with that number 3. Okay. All right, so let's take a look then at number 6. Number 6 might be a little bit different since it's a 1 to 2,000 solution. They've ordered prostigmin. We've ordered 0.5 milligrams, and that prostigmin is a 1 to 2,000 solution. So remember that means 1 gram per every 2,000 milliliters. So when I fill out DH and Q, it's going to be 0.5 milligrams over 1 gram times 2,000 milliliters. So making sure D and H are the same unit, just as we've been doing. 1 gram is the same thing as 1,000 milligrams. Now they're both in milligrams. So I'm going to take 0.5 divided by 1,000, which gives me 0.00005 times 2,001. Our answer here would just be 1 milliliter. So that's how we would apply those ratios. Again, just doing another percent example, I'm going to take a look at, say, number 9 on the next page, on page 361. Number 9 says that we're going to order 25 milligrams, and lidocaine comes as a 5% solution. So keep in mind that 5%, that's the same thing as 5 to 100. So just as we looked at with our last 2 ratio examples, anytime we have a ratio, it means that first number is how many grams we have per the second number in milliliters there. So filling out DH and Q would be 25 milligrams divided by 5 grams times 100 milliliters. So making sure D and H are the same unit as usual, we're going to convert those 5 grams. That's the same thing as 5,000 milligrams, so I want to see that so that they'll both be in milligrams. And now I can go ahead and divide this out. I'll take 25 divided by 5,000, take that and multiply by 100. That gives me 0.5. So my answer here would be 0.5 milliliters. So that's our dosage calculations. As you guys see those, I did send you guys videos. You guys have these videos in your email along with the review videos for this chapter, or for these few chapters that we went over today. Go over those. Make sure you study those. We will have a quiz at the beginning of next week. There is a Connect assignment posted for our dosage calculations chapter. So those of you guys that are doing the Connect assignments, look out for the Connect dosage calculations homework. Make sure you do that. For those of you guys that are not doing the Connect, I have provided your sub. I have provided the printouts for the dosage calculation, so make sure you collect one of those on your way out. Okay, guys, hope you had a great week, and I will see you guys next class.